We're talking about sampling next. Remember, if we think back to our last lesson, we said that the key idea in this course is I don't know um, enough about my population. I can't get my hands on all of it. So what do? I take a sample, and as I have to check it to see if it's a good sample. We'll talk more about that today. And if so, then I can use that to make an inference, right? So let's talk a little bit about sampling methodologies. The first set here are probability samplings. That it's subcategorized under that is not really pivotal. We have systematic sampling. Um, Notice in your notes I have this definition written small. That means it's not something that you have to write in. And of course, what I'm telling you with that is I want it there for the completeness of the notes, but it's not something that is super important. So it's a type of sampling method it's good for you to have in your notes to reference, but we're going to talk about it a whole lot less than the other three here in this bullet that we're going to write down. So simple random sampling, a sample where all samples of the same size have an equal probability of being selected. Now that sounds a bit weird potentially. Another way to think about a simple random sample is just your basic sample like you're used to seeing. If you think about pulling names from a hat, if I were just put all the names in a hat or all the balls in a you know machine, you have the draft lotteries in sports, right? They put all the ping pong balls in the machine, you pick one, right? If there's one ball for each team, right? Everyone's got the same chance. And that's a simple random sample, just your basic, everyone got the same shot. Okay, so your basic normal, everybody's got the exact same shot of being selected type sample. And that is the general way that we want to sample, but not always. So here's where I want to make a distinction. Some textbooks, some teachers will say that we always want a simple random sample. And that's true most of the time, but not always. Simple random sampling is very good. There are times when we need to do a different type of sampling. We'll cover that here shortly as to when we would want to do something different and why. But for now, I just want to kind of lay down that foundation that says simple random sampling, usually the best way of sampling, but not always. What we really want to focus on is less, is it a simple random sample and is it an appropriate sample? Let's kind of raise that definition a little bit more, raise that umbrella a little bit more and say, is it appropriate? And oftentimes the answer to what's an appropriate type of sampling, the answer is simple random sampling, but not always. And again, we'll touch on that in a minute. The other two types of probability sampling we're going to touch on, stratified. Stratified sample is a sample where the population is divided into groups, into subpopulations. We call those strata. You don't need to focus on that they're called strata. That's just drawing you back to why it's called this. But we divide the population into groups, and a sample is obtained from each of those groups. And we're going to contrast that with cluster sampling, which is very similar in that we're going to take a sample and we're going to divide it into, and now we're using the term clusters here, and I'll talk about why we use that term, but groups. You could have changed the word here in subpopulation into groups and that into groups, and basically said both cases we're taking a sample where the population is divided into groups, but then it's different as to what happens in the stratified sample. We take a sample from each of the groups, whereas in a cluster sample, we say every subject within some of the groups is sample. So another way to think about this is, are we taking some people from all groups? That's stratified. Notice a sample is taken from each, from all groups. So some from all is stratified. In cluster, we're taking all from some. Notice every subject, all of the subjects within some of the cluster. So some from all is stratified, all from some is cluster. And so it's the idea of when I break down my groups, is it more important to make sure I get some people from every group, or is it easier for me to just take a handful of those groups and just ignore some of the other groups? Oftentimes, the answer is going to be that you'd rather stratify than cluster. Cluster is used for convenience when you say the groups don't have any real difference. Okay, so let me give you this example to really help nail down the difference between these two. We can divide our states, our country into 50 groups by state, right? That's an easy way to divide into subpopulations. In some cases, I would say it's probably more appropriate that a good sample is I get some of the people from every state. In that case, you may think property values. You may think incomes, right? People in New York City make a whole lot more. I mean, people in the Bay Area, right, in California, make a whole lot more than people in, Montana do, right? Um, if you were to think about a lot of racial statistics or a lot of age statistics, you probably would want to stratify because you would say the age breakdown is, a lot of older people living in, say, Florida and Arizona, right? Or when you think about racial, you think about, we have clusters of different races that live in different proportions in different states. Some states are just very white, other states much less so, right? And so that's just um, a situation where you say the groups, the states are all different enough that I need to get a little bit from each one of them so that I'm representative now of the country as a whole. In some cases, you would say there's really no difference in my groups. And if I have the data, it may just be easier to get a bunch of people from some of my groups and say they're all the same. It's not a big deal, right? If I were to say um, something about number of people in each household, that's something where, in general, I would say it's probably about the same across all of the states. Now, maybe you could dive really deep into that and pick some holes in that, but in general, I'm going to say that people tend to, in this country, tend to have about the same, same number of kids, whether you live in Florida or Georgia or Illinois or Washington, right? It's probably about the same. And so in that case, I could just take everybody from a few states, and that's probably representative enough because I'm not overly concerned about what's different from state to state. So that would be a situation where I could use cluster sampling just for the ease of not having to, say, travel or contact, um, you know, all 50 states. That's the downside with stratified is we have to contact every state, all 50 states we have to get data from, right? Might be a little bit of a pain, but you might say it's worth it if those groups are different enough. We have some non-probability samples. Again, just some definitions here for you to have for completeness already printed for you. The biggest one is a volunteer response sample. This is defined many different ways in different textbooks. I've seen 100 different definitions. I finally settled on one over the years that I like because it goes to the heart of the matter. Volunteer response sample to me is a sample where if you want to be included, you have to do something inconvenient. You have to go out of your way. And that's not typically a good thing because if you have to go out of your way to be involved in a sample, it means you probably feel very passionately one way or the other. Remember, the key to all of this, what you have to remember as we go forward, is our samples, we want them to be representative of the entire population. If I only get people who feel very passionately, whether it's for or against something, left, right, whatever it may be, if I only get the people who are extremely passionate, then I'm not representative of what that middle looks like, what the people who aren't necessarily extremely yes or extremely no might be. And there might be a lot of mild yeses or moderate yeses. There might be a lot of mild no's or moderate no's, but I have no idea because those people aren't as passionate, they're not going to go out of their way to be included. These are the voluntary response samples are the things where um, you might have to pay for postage to mail something back. And a lot of people who don't care that strongly would say, whatever, I'm just going to throw that away. Or if you're browsing the internet, a pop-up browser pops up and says, do you have time to answer a poll about how you feel about anything? Whether it's the current president, say, if it pops up and says, would you like to vote or respond to if you approve or disapprove of the current president? Well, if you kind of feel met either way, you're just going to hit the X button and say, I don't have time for this. I'm doing something else. But if you feel really strongly one way or the other, you might decide to answer that. Well, again, now you might know how that sample might tell you how the top 20 or bottom 20 or top 10 or bottom 10 or whatever percent of people may feel. But we don't know if the rest of that middle group shifts one way or the other. So we're not representative, right? So that's why voluntary response samples can be a problem. Now, the natural follow-up to that is, well, why even have them? Sometimes that's all we can do. Sometimes it's not possible to do better sampling. So there's a lot of nuance as we move forward in this class, and we're seeing it right here in that what we would say is that a voluntary response sample is not ideal, it's not good, it's not what we want more times than not. Sometimes it's the best we've got. And so what we do is we take that sample, we analyze the data, we work the problem, we draw our inferences, but we have to come back and say, the sampling method wasn't ideal, wasn't very good, and so this is better than nothing, but maybe we don't put all our eggs in the basket trusting those results because maybe they're just only so-so results. Okay, and that's the nuance that we want to think through as we talk about, is our sample representative? If it is, good. If not, we say maybe the inference that we make isn't to be completely trusted. So some examples: to estimate the percentage of defects in a recent manufacturing batch, we select every 8th chip that comes, starting with the third until we get 140. And it's not a definition we wrote down, but that would be systematic. We just picked every kth subject, in this case, every 8th one. So we had a system to how we picked people. Member of Congress wishes to determine her constituency's opinion regarding estate tax. She divides her people into 3 income classes and takes a simple random sample from each income class. So already you're seeing here now is this stratified as this cluster. We're taking our sample, breaking it into groups. Then what do? What we do is we take a sample from each of the groups. And so that would be a stratified sample. Now notice we can then add on the adjective of a random stratified sample because this was a simple random sample of each one. So notice there, again, that's not a huge thing, just something just so you can catch, because you might be watching this going, wait, what? We didn't define random stratified, we just defined stratified. Stratified just means I broke everyone into groups and I took some from all. How did you get those some people? If you just took a sample but it wasn't random, then that's just stratified. But if you took a random sample of those groups, then that becomes random stratified. Okay, so just a little extra thing to catch there. To determine the prevalence of HGH among some baseball players, we randomly select 50 high schools. All members of those 50 are tested. And again, same thing, we've now broken our sample into groups. The groups are all the high schools. How many high schools are there, in the state? Well, it depends on what state you're at. I guess it doesn't specify, but we would say presumably many, many more than 50. So we took a handful of the groupings, and what we did is we took all from some, which makes this cluster. And notice because we randomly selected which ones, that then becomes random cluster. Had we chosen the 50 based on convenience, then that would just be a cluster sample. But because we randomly chose which ones, it's a random cluster. And this is what I was talking about earlier. If you think about it, if you have reason to suspect differences in the high schools, this wouldn't be appropriate. You'd want to stratify. You'd want to take some from every high school. But if you said by picking enough high schools, those differences will kind of come out in the wash. If you said, yeah, there's some differences in sizes and rural versus urban and good programs versus bad, but if you said if we get 50 of them, we get a good cross section, it's a whole lot easier to go to 50 schools and test those players rather than go to however many hundreds or thousands of high schools there might be in a state. And so you might have some convenience by doing the cluster sampling in this case. And the last one, in an effort to identify if an advertising campaign has been effective, we take a nationwide poll by randomly selecting individuals from a list of known users of the product. And this one sometimes catches people. This is just a simple random sample. We don't really care much about the list. The bottom line is we took everyone that we knew used the product, so we took all the names, and then we just randomly picked. So again, we just threw everyone's name in a hat, and obviously we probably didn't throw them in a hat, but figuratively speaking, if you want to think about it that way, this would just be a simple random sample. Again, usually the type of sampling we want, but again, not always.